We are given a Bernoulli counting process X that has probability 1/4 of success on each trial, and the trial time frame is delta is equal to 1. And X is expressed as the sum of the trials that have happened up until the current time. EI is the event that the ith trial was successful, and so 1 EI counts when that event was successful. We were also given a lambda is equal to 1 Poisson process, which is independent of X. We were asked to find the probability that X of n of 5 is equal to 1 given that the first trial is successful. So given E1 or given the Bernoulli 1 E1 is equal to 1. So we need to have at least one trial to be able to have had one success. So we need N5 to be at least 1, and we need the sum up to N5 of 1 EJ to be equal to 1. And we need N5 to be at least 1 for that sum to be 1. And now we can look at the probabilities. So the probability that we had one success, exactly one success at random time N5 given E1 is equal to the probability that we had exactly one success up to N5 and we had a success on the first trial over the probability that we had a success in the first trial. This is just by elementary probability. We think of the sum of the 1 EJs to be equal to 1 as A, and the event E1 or 1 E1 is equal to 1. They're the same event to be B, and we just perform the probability of A given B is the probability of AB over the probability of B. Now the denominator in this form, the probability that 1 E1 is equal to 1, is just the P, the success rate, the Bernoulli trials, which we were given as a quarter. So the denominator is a quarter, and so what we're left with is the same numerator with a 4 out in front. And now to evaluate that, we can use total probability. So we can leave the 4 alone, and we can expand the numerator out over the number of trials the Poisson random variable is going to give us, i.e. we can sum k is equal to 1 of the probability of the summation j equals 1 up to k, so we're substituting k for n5 of the 1 ej being equal to 1 and 1 E1 being equal to 1, given N5 is equal to K times the probability N5 is equal to K. Now we were told right away that the Poisson process was independent of the Bernoulli counting process. And what this means is N is independent of all these events EJ. And so the conditioning on the total probability line above does nothing, and we can just remove it. And the result is this expression by independence. Now at this point we can just substitute in the value. So we can leave the summation of the k alone, we can leave the 4 alone, and we can substitute in the probability that n5 is equal to k, which is just the probability mass function for a Poisson where mu is equal to lambda times 5, which is equal to 5. And so that would give us e to the minus 5 to the k over k factorial. So now for this probability of the sum and the first condition, what we can really recognize is that's the probability that we have E1 and then not E2 and not E3 and not all the way up to not EK in these trials. And so we have K minus 1 failures and 1 success. Moreover, that success comes at the first trial. And so we have P times 1 minus P to the K minus 1. And we substitute P in and we get 1/4 times 3/4 to the K minus 1. Then we just simplify terms. What we can do is you can bring the 3 and the 5 together and then multiply by another 3 and divide by another 3 and get 15 to the k, and then we can handle the force, and we can see we have 1/4 to the k minus 1 and then another quarter, so that's just also 4 to the quarter. So we're left with 15 over 4k times 1 over k factorial, then that's all summed, k is equal to 1 to infinity, and multiplied by 4/3 e to the minus 5. Now the summation k is equal to 1 to infinity of 15 over 4 to the k over k factorial. Well, that's the exponential expansion, except for we don't have the k is equal to 0 term, i.e. we don't have the 1 term. And so we can add and subtract 1 to get e to the 15 over 4 minus 1 for that factor, pre-multiplied by 4/3 e to the minus 5, and then substitute everything in the calculator to get 0.373023.
Dear U of A students, while Mike has supplied the content for these videos, there is significant unpaid effort that goes into producing these videos. The folks here at Step by Step Probability are family people with young children that no longer attend school due to the COVID shutdown. Instead of spending time with our families, we have made arrangements to continue producing these videos for you. In these uncertain times, it would be very encouraging to see your support through our donation button at the top of the website. Any amount is encouraging and appreciated. Please donate if you can. Thank you, and keep safe.